Okay. Now we'll move on to measures of central tendency. So, which I'm sure you're all. Oh wait, no.
Oh yeah, sorry. Before we do that, yeah, just introduce you to the data set we'll be using the most for during this course. So this is a data set of snow leopards, which I call the UNCIA data set. It has 110 snow leopards, and it's a data that has measures of length, which is essentially just from the snout to the base of the tail in centimeters. It has also another column called weight in kgs. So for each of these individuals, there's also 2 extra variables. It tells me if for each leopard, whether it's male or female, and the location. I put a map so you can get an idea where these locations are. So I hope everybody got the message that I sent yesterday about so I sent the data set to everybody as a CSV file. You can work on the same the same project that you have, and if you write the line that I put here, so you would create an object called uncia, assign it, and using the function read CSV, so your computer will. Oh, sorry, I forgot to do something before we do this.
Working directory.
To set the working directory, because so I'm just gonna get back to R very quickly. Okay, something you should make sure that so for this to work. So the project that you're working on has a working directory. This is essentially the folder you're working from. So if you're referring to a file like we're just about to do, R knows that we'll look for this file in the directory that you have for the project. So to do this, you do that. So you can do that. You will go to the Sessions tab and set the working directory here. And you can choose a directory. Okay, I would then browse to the folder where I'm working from. So for me, the SLN course 2021, and it sets the directory to that folder. So if I refer to this uncia.csv file, it will know where to look and it will find it. But if you have this data set in a different folder, then it will not find it. So make sure to have this uncia.csv in that folder you're working from, and it should match that working directory that you have. The working directory is also there at the console. If you look right above the console, it tells you which one is your working directory. You can also check your working directory with get wd. Oops. And this will just tell you which is your working directory. You could also manually set your working directory in the console with set working directory, and you will put in between. So you put quotation marks and put the file path in there, and that would also set it. But I'd advise you to use session and set working directory. Then you can avoid any error by doing this. Okay, so back to the presentation. Okay, so please try to do this and write and create an object called uncia, reading using this function read CSV, uncia.csv, header equals true because it has headers. The names of the columns are in that CSV file. You may run into some errors because sometimes the separator that is used in the CSV file, by default, it should be a comma, because that's what CSV means. It means it's a comma separated value. So anyway, if you do have problems with at this step, I can troubleshoot it with you, no worries. Just write in the chat if you realize that your object is not looking like what it should look like, basically. Okay, I guess, and you want to?
Yeah. Okay.
So, oh yeah, so try it. If you tap structure after loading this CSV file and creating the other uncia, if you look at the structure of uncia, you will find it should return this. It should return that is a data frame with 110 observations, 5 variables. So that's 110 leopards. So these are all the rows, 5 variables. So that would be, so there's a first variable called x. This is X would be an integer from 1 to 110. That's just the row number, essentially. There's also a character column, which is a categorical variable called wakan. This is called location, and this has the 2 locations. It has another column called sex, which is it's another categorical variables to tell you whether the leopards are males or female. And there's 2 numeric variables. Well, for now they are integers here, which gives you the length in centimeter and the weight in kgs. Okay, now you can take over.
So just to make sure nobody had trouble running that, right? For everybody, it worked. Yes, unless we see a comment, I'll assume it did. So now we move on to the descriptive statistics. Now, this is something I'm sure most of you have already probably worked with and extracted for your data. But when it comes to, so first and foremost, when it comes to statistics, what are we doing? What we're doing is trying to figure out, let's say, what is the size of leopards in the Himalayas. So when you say that the leopards in the Himalayas, what you're trying to do is get the size of that population. In statistics, a population is the data, or like basically the real world thing that you're trying to get the information about. And how you do get that information is by sampling the population and figuring out the rest of it from there. So for example, if I sampled 100 leopards from the Himalayas, then my sample is the 100 leopards, and the population that I am trying to figure out all of these stats for is the leopards of Himalayas. So this is one thing that you have to always remember in statistics. A parameter is the equivalent statistic of the population, and the statistic is the statistics of the sample. So let's say when we talk about mean, when you say mu, that's the parameter, and when you say x bar, that is the statistics, and that's always what we're calculating. Mu is technically an unknowable entity, and we only estimate what it could be by calculating the x bar. So to start with, yeah, and similarly for sigma, like sigma is the standard deviation of the population, whereas S is the standard deviation of our statistic. And this is just a notation thing, but size of the population will be referred to as capital N, and small n is always the size of your sample. So once you've gathered, let's say, your data from this big sample, what is the first step you try to do? The first step might be like trying to figure out, okay, what's the typical, size of the leopard of the Himalayas. Let's just continue with this example. So the first thing that you would try to do is figure out a measure of central tendency. That is to say the typical value, which can be calculated in many ways. One of the most common ones that mostly everybody and most hypothesis testing tests use is the mean. Then next slide.
Yeah.
And how you would calculate the mean is pretty simple. Like if I were to ask you like how to calculate the mean, I'm sure all of you would know. It's just the sum of all the values you have divided by the number of values. So let's try running that in R as well. So the code is given here, but so as you can see, there are multiple. So as always in R, there are many ways you can do this. One way would be to calculate the sum of the length of just that one column. So when you say a dollar length.cm, you're referring to that particular column. And n row stands for the number of rows in UNCIA. So that's just another way of getting number sample size. And the second one would be the sum of all the lengths divided by the length of that particular column. That's instead of n row, you're just calculating length of the particular column. And obviously there's a function for mean in R as well.
Yeah, so just to be clear, this the first and the second line, they do exactly the same thing. Well, so does the third line. In the first line, n row UNCIA will return 110. That's the number of rows in UNCIA. So that's your n here in the equation. And the length of UNCIA $length, which is that column, the length of that column is also going to be 110. But n row will only work on a data frame, right? Because it's the number of rows of something that has rows. So that's why we can do n rows on Uncia. If we try to do n row on Uncia hashtag, sorry, $length, it will not work because it doesn't have rows. But the length of that vector, however, is going to be the same as the number of rows for the data frame. Yeah.
And there should be one more way of doing this using square brackets. So if anybody wants to give a shot at that, you can put the answer in the chat.
Yeah, just try to write this, try to get the same result, but instead of using this $, yeah, the square brackets like I did, like we did together with the plants. So I'm just gonna wait for.
Yeah, we'll give you a couple of minutes to run this.
If you have any questions, you can always unmute yourself.
Yeah.
No problem. I will write the answer in the chat, I guess. Also, if anybody is running into problems at this point, when you loaded the data frame from the CSV file, there may be some issues there because it's always consistent the way it works. But anyway, that should work.
Ranjana got it. Yeah.
Nice. Okay. Mean of Uncia in the fourth column. Very good.
Yeah. Basically, square brackets fourth column is just another way of, like Guillaume said, referring to Uncia $length.cm.
Yeah.
They're doing the same thing, just different ways of doing it.
All right. Very nice. Okay, so we can see that, yeah, the mean value for that particular, for these leopards is 102.1 centimeters.
Yeah, Aliana got it as well. Sorry, yes.
Nice.
The mean value is, you want to just?
Yeah, very good. Nice.
Okay. All right, so now the next thing.
Rohit had a clarification and before Ranjana and Alena.
Yeah. Oh, there's no, not clarification. They're just giving the answer to the question. So yeah, they've done the same thing. Instead of using the $sign to refer to the particular row, they've used the column number. It will do basically the same thing. So you get many ways to answer. Yeah. And so one of the things about mean is, because you're actually using every single point in the data set, even if you have very out there values like outliers, they will influence the value of the mean. So let's say, you were looking at the household income of everybody in a particular village. If let's say there were two very rich people and the rest of the people were just okay or below average, a mean would paint a very false picture, because you would get a more, like, the average you will get would be actually much higher than the average person you're wanting to look at, right? So in such a situation, what you would do is use the function, use the statistic median. Median is the statistic that's halfway through all of your data points. So let's say you have like 5 data points, like we did for the plant. We had 6 for the plants, right? Yeah, 6 data. Okay, let's assume it was 5 because it will be easier to start from there. If it was 5, then the third data point, it's the halfway through once it's arranged in ascending or descending order. So once you've arranged all the plant data, the third position would be the median. So median is technically only position. There's no calculation involved here other than ordering the data set so that it's in ascending or descending order. So R has a function that you can use to calculate median directly, but we've also added a couple of extra ways you can do it, so that just to get a handle on practicing R. So in this, as you can see, the first line of code, what it does, order. When you run order on Uncia $length.cm, it will give you a string of numbers, which is the position of each value in length.cm in ascending order.
Okay. You should try this. Like, try to run the slide and look at what length index looks like as an object.
Yeah, we'll just open R here also.
We can open R.
Yeah.
Where's my R? I need to, because I didn't do anything. So okay, now for the UNCIA data set, I will import UNCIA with read CSV. So this is something we did already. The name of the file, which is in the same folder, I can actually look at my files. And when I created the project, I can see all my files in that folder. And I can see there's UNCIA CSV, so we're all good. UNCIA.csv, don't forget to put the .csv. Header equals true because it has column names. Boom. Okay, so I have now a data frame called UNCIA, and I can look at it. So with structure UNCIA, so I get what we already had. Very good. By the way, I could also like click on this to like get a new tab, and I can even see the data set. So that's a lot neater to look at. Okay. I'm happy because length is already an integer. It's not a character, so I don't have to do any conversion. I don't need to like specify, okay, this is a number, treat it as a number. Because if I want to do any ordering on this and it's a character, it will not work because R just does not know which character is bigger than the other, right? But at this point, it's fine. It's a number. So the next thing we want to do is
Order. Length.
Order, yes. So it was, I think I call this length index. Let's look at, okay, let's just look at this. If I took UNCIA $length, I get all the lengths, right? In like row by row, right? So first it's 109, the second row is 106, and so on. So they are scrambled for now, like they're not ordered from low to high. If I type order, UNCIA length, let's see what happens. If I run this, now I get a bunch of numbers, but these are not the lengths. These are actually the positions. It tells me that the smallest one, the smallest possible length is the 15th length. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that's the smallest length that there is. This is what it does, this order function. It tells you, the first one is actually the 15th one, then comes the 13th one here, and it does that for every length. So this will allow you to order them, basically. So I call this the length index, which I can use. So I'm going to create an object using the last line that I had, which is order UNCIA length. Okay, so I'm creating another like this. So these numbers here will just be put as a vector, which is good because then I can use that object. I can use the length index, and I will use it like this, called length. So I'm going to create another vector. Oops. I think I call this length order on the slide.
Yeah.
So length order will be UNCIA length. So I'm still going to refer to that column. And then I will put the square brackets here. And remember, the square brackets is the indices, right? So for example, if I put UNCIA length in brackets 1, sorry, I'm just going to run this so you can see what happens with the square brackets. UNCIA length 1 is simply the first one, right? UNCIA length 2 is the second one in your column. If I put UNCIA length 1 to 10, it gives me the first 10, okay? If I put UNCIA length and maybe like I put, first I put the 15th and then the 18th and then the first one, it will give them in that order. It will first give me the 15th, then the 18th, then the 1. And remember, this is what this length index is. It gives me these positions. So I can simply use it. If I, instead of doing this manually, I could just put that object that I already created, which has all this information. So this is all the indices. It will return the length in the correct order. You see? And And from this is good because then we can use that to identify what the median is. As Anne explained, the median is like if you ordered all your values, you just take the one that's exactly halfway through. Exactly halfway through is not going to work always, because sometimes, so if you have an uneven number of observations, halfway through will be one of these observations, right? If you had, let's say, 3 numbers, halfway through would be the second number. But if you have an even number, it's a bit trickier, because then, okay, let's say you have 4 numbers, halfway through these 4 is going to be between number 2 and number 3. What you do then to get the median is that you just take these 2 values and take the average of the 2. That will be your median. In our case, it's actually an even number. We have 110 observations, so it will have to be something that is falling in between. So if we counted, we have 110 observations, so we would have to go on observation number 55.5, which would be, so that one is observation number 45. I can go from here, 45, 46.
So what you can do is assign it to an object and just isolate 55 and 56.
Yeah, actually we could do that. So if we have uncia length reordered like this, so I'm going to create, now I'm going to create an object so that I can use it, which I'm going to order. Probably work on the script so that I can. So first we had get the median. So first I'm creating that object. Length index, this, and length order is that. Whoops. Oh, what am I doing? Oh. Okay, length order, not uncia order. Okay, if I do this, I can look at length order again. Oops, what has happened? Oh, why do I have so many NAs? It's just, I'm just going to rerun it from the beginning. I must have done something that overwrote something else. No, I still have NAs. Why? That's strange. When I look at uncia now, uncia looks fine. So what is going on?
Because
oh, sorry.
Yeah.
Okay, that's wrong. That's not what I want. Oops. This is order. That's what I wanted. So first getting the order, then rearranging length and creating this object called length order. And if we look at it, it is rearranged. So I could isolate. I know I have 110 observations, so I know the median should be at observation number 55.5. So obviously I can't have that. If I try to refer to observation number 55.5, it will send. Oh wait, actually it does time. Okay, thought it would send me a message, an error. But what I could simply do is get observation number 55 and 56, right? Which I can get like this, or simply putting number 55.2 for number of observation of 56, and it will return these 2 values. So we can see that, okay, actually the average between these 2 values is going to be 105. So, and that's the median. Median would be then 105.
Yeah. Or you can run the median and in brackets the object that will also give you the median.
The median. And as an of length, or you can just put that the median of uncia $ length, it will give you the same answer. There you go.
And just so everybody knows, like instead of doing this long about way of ordering and then making a object based on the order length, there's also a function called sort, which will just give you the.
Oh yeah, I could just show this. Sort, the sort function, which I myself forgot about, that Anne reminded me of. So I kept doing this order nonsense with like, because it's 2 steps, right? You have to first order and then rearrange based on that order, but the sort function does all of this in 1 step, which is pretty handy. So if I just sort uncia $length, this is what happens. It's basically these 2 steps in one with 1 function. So yeah, the sort function does that. But yeah, again, this is only if you want to work out the median manually. You kind of want to sort them out and then you go in between, in the middle. Oh, someone is asking about descending order. You can do that.
You have to put descending is equal to true. That's all. Because the default in both of these functions is that it's descending is equal to false.
If I get the help file for the sort function like this with the question mark sort, I will see that sort has, yeah, by default has decreasing equals false. So you just put decreasing equals true and then you'll get that. All right. You could also do this like this with the if the 2-step version. If you simply added a minus here, because minus will give you. Wait, I think it will work. Let's see.
Will give you?
Okay, no, my bad. It doesn't work like this.
Okay.
Never mind. So wait, I guess just use sort if you need to. But again, there's a median function anyway, so you don't need to do any of this with the median function. Right. So where were we? Okay. The third line here, by the way, is simply it's a formula to calculate the median. That's officially, you just take the length of your vector, which would be 110, add 1 and divide by 2, and that gives you which value it should be. It will give you 55.5. So at which point, which one is the middle point? You look at that value on the ordered data set and you'll get the median also. The quantiles. So, oh yeah, okay. So I guess I'll do this. So the quantiles is, so if you think of the median is essentially the second quartile. It's bang in the middle, right? So if you divided the data set in 4 portions, quartile number 2 would be the one that's in the middle, and of course that's the median. So quantile essentially allows you to, again, from an ordered data set, you can get the value or the average value for your variable at a particular point in your data. And this is what these quantiles do. So sometimes it is useful to obviously get the median, the second quartile, but maybe you want, which you can calculate also with this quantile function, but specifying 0.5, which means like 50%. So this is where you want it. So you call this a quartile, the second quartile. You could also try to, in the same way, by modifying that line a little bit, you could get the first and the third quartile, which are these values here. So I think you can appreciate, the first quartiles is when you move through your data set, your ordered data set. This is in black here are all your length value. In red, I put the actual index. So that's the first one, the second one, the third one, and so on. At 55.5 here is your median. If you isolated only anything that is left of the median, you could get the median of that, and that would fall a quarter in the data set, right? And that's your first quartile. And for this, of course, you just need to put 0.25 to get the first one. For the third one, you put 0.75. I combine these two so you can get both values together. So if you put quantile at 0.25 and quantile at 0.75, combine these two with the C function, it will return both values together. So you can try this in your console if you want. Apart from quartiles, we can also talk about deciles. So if you divide your data in chunks of 10, 10 chunks of data, and you see what values fall at the boundaries. So the fourth decile would be at 0.4, of course, and that value would be 100.6. You can also even look at an even more precise even more precisely so you can look at percentiles, let's say. And again, you can specify, okay, percentile 87, so 87% of the data set would fall at that value, 120.66. These are just a few examples. It will probably never be useful to look at the percentile 87. But sometimes you might want, I don't know, percentile 95, or if you just type quantile without specifying where you want, for which value you want it, this is what you'll get. You'll get a summary. It will give you simply the quartiles, I think. It will give you at 0%. So essentially the first value, it will give you that value, 41. It'll give you the first quartile, the median, the third quartile, and the maximum value as well. So you can try that. You can try typing simply quantile of the UNCIA, the length column of the UNCIA dataset. It should return to you, it should return 5 values. And these are probably the most useful. You know, it kind of gets you an idea of like where your data is standing and how rich. But apart from quantiles, okay, someone is asking, why do we choose to write some code and some in the script? Oh yeah, sorry. So the console will just run the code that you write. The script, so you can run code from the script. What the script allows you to do is just that it's basically a text document. So it will stay there. In the console, you just type things and then it moves on, right? I hope that's clear now. Cool, so let's continue. Maybe Anne, do you want to jump in? Okay.
You can continue, it's fine.
I'll continue? Okay, fine. Okay, so now we have an idea about the central tendencies in our data set. We know where the median is, we know the central value, we know the mean, which is kind of close to the median, but not exactly. But the median and the mean don't tell you anything about how your data is spread. Like, are all the values kind of close to the mean, or are they really spread out? Like, are they kind of really evenly spread out, like with all values kind of equally frequent? Or not. So this is where like you want to assess the variation in your data set. So what I'm just about to explain, that's what they are useful to understand how spread is your data. So one very simple thing you can do is to get the range. So you get the maximum value in your data and the minimum value. That already tells you something about like the spread of your data. Nothing will go beyond or below the maximum and minimum value. So the range you can simply calculate by subtracting the minimum value in your data to the maximum. So in our data set, I think the minimum value was 41, and the maximum was 150, if I'm not wrong. Subtract the two, and you get 109. So that's the range of your data. Okay, that's all good. That's kind of informative, but not completely, because what if you have a really big outlier? And actually, you'll find in your data that maximum value, 150, is not very common. There's basically one big leopard in our data set. And of course, the range will end up being larger. And it's not going to be representative of the other leopards in the data set. Like, it won't be representative of most leopards, simply because we have this outlier there. So the range may not be super useful. We can look at the variance instead. The variance, as you can see what it does, so we know the variance for the sample, we call it S squared, all right? And you'll see why in a second. The variance is simply the sum of all the values. So you take any value, the first value in our data is, for example, 109. You subtract the mean from that, the mean was around 102. And you square that. We square it because we don't want this to be negative. That first value, for example, is bigger than the mean. So if you, so you will, if you do that value minus the mean, you will end up with something positive, which is fine. But for any value that is below the mean, and of course there are quite a few values that is standing below the mean, then that part here will be negative, which is why to calculate the variance, we square it, because squaring will make everything positive. And this will end up being kind of a measure of how distant are all the values from the mean. So if your data is really spread out, the sum of all the distances squared will be it will be a very big number, so the variance will go up. So a higher variance tells you that, okay, most values are not close to the mean. They are quite far, and so putting all these variances together, you summing them up, it will end up a big number. We do divide it by the number of observations, of course, -1. I won't get into details of why we put this -1. And essentially, so the variance for that data set is 365.1 approximately. So you can try this. You can calculate the variance like this. So I can just take the formula and kind of replicate this formula exactly as it is in this line. So we have the sum of each value. So you take all the values, you divide it, you subtract the mean from each of them. So you'll get another vector equal to the length of that, essentially. And you get the sum, and you square that. You square this. Wait, did I make a mistake? I think that's fine. Okay.
Yeah.
No, I think the square should be somewhere else. Oh, my bad. Okay, I think the square should be inside the square bracket. Anyway, you can check whether you get the same answer here or not. Otherwise, it means I made a typo, and that hat square here should be inside, like between these two brackets here, I think. Someone can check and let me know in the chat, actually. If you write it as it is here, I think you will get a different number.
Because it's square of the difference, not square of the summation. So it has to be
exactly. That's why I think it's as it is. It's wrong. I could change it now. Why not? So, whoop. No one saw this. Okay, so there, I think it should be like this, and then you'll get the same answer. Of course, R also has a base function called var, and that calculates the variance for that. So, of course, that's just a very easy way to get the variance. So you can appreciate that, of course, the variance can get massive, right? If a lot of values are quite far from the mean, the variance can become really, really big. A lot of the time we don't use the variance, we use something we call the standard deviation. It's simply the variance, and you just square it. You square the variance and you end up with the standard deviation, and we just refer to this as S. So variance is basically the standard deviation squared. If you take the square root of the variance, you end up with a standard deviation. So this is trivial, we call it. You can go from one to the other by a simple calculation, by simply squaring or taking the square root of the other. So if you know the variance, you also know the standard deviation and vice versa. The standard deviation for our data set here for length is 19.1. And yeah, so this, it does. So this, what it does, measure the standard deviation. It measures how widely scattered the measurements are from the mean. And you calculate that as the square root of the variance. So yeah, pretty standard measure in statistics to describe your data set. And and this is the code to calculate the standard deviation. Again, you can simply take the square root of the variance, or you simply type SD of that. And I forgot a square bracket here. I will correct it here now. And that should give you the standard deviation. Do you have any questions at this point? Anybody? Just wait 1 minute in the chat. Okay, and I'm sure for a lot of you, this will be very familiar. I guess it's also sample. Yes, so Adi Priya is asking if the SD is a sample SD. Yes, it is.
It's always the sample SD, like, because technically the population SD is unknowable. We estimate it using the sample SD.
Yeah, unless you do end up catching all the leopards in the Himalayas, then you will work with the population standard deviation, which will be a parameter. But yeah, essentially we end up with that statistic, the standard deviation, and that statistic is basically an estimate of that parameter, which is the population. All right. So I think so far so good. One last, So there's other measures. We're not talking about all the descriptive statistics that exist. I guess you could look these up on your own time as well. There's other things. So there's kurtosis, skewedness of your data. Here we're really presenting you the most common ones and the ones you will probably use, like if you write a report or a paper. So if you describe a data set in your paper, you will probably, you'll tell the mean and you'll tell the median and maybe the standard deviation also probably. And that should be it. And this, of course, again, is for continuous variables, for numerical variables. For character variables, I guess we'll do that maybe during another session. Of course, these don't apply because all of the statistics we're presenting to you right now, these descriptive statistics, will only work on numbers, not on characters. For characters, the most common thing to do really is to just say, okay, I have two locations and I want to say, well, 50% of my leopards are from that location and 50% are from the other, or maybe it's 40, 60%. That's pretty much the only kind of statistic you will present for character variables, like how frequent they are in your data set. Okay, lastly, it can be very useful to look at the mode, so to get an idea of how frequent some of the values in your data set are. And that's what the mode is. It's just looking at the frequency of these values and telling you, okay, which ones are the most frequent. So sometimes you have only one mode, like there will be one value that is very frequent. In our data set, as you can see, there is two. So you can inspect the number of times value appear in your data set by typing this table function. The table essentially counts how many times each variable appears in your data set. So it will give you a count. It will tell you, for example, that 109 appears once, I think. You can check this. So if you type this in the console or in this, put this in the script and run it, you'll get that table and you'll see how frequent these values are. And you should find that values 106 and 116, they appear 5 times. So these are our modes. You could say it's bimodal in this case. With 106 and 116. You could also just instead of looking at that table and trying to find which one has the highest number, and which might be difficult to look at if you have a lot of observation and your table is massive. So of course, making that histogram you can just visually appreciate, assess visually which ones are the most common values. You can also run this code to isolate. So this code is a bit complex. This is maybe for people that know R already a little bit. Maybe you want to look at that line of code and trying to figure out what I'm doing. But if you run it, you'll realize that what it does is it's isolating the values in that table for which it is the maximum frequency. So 5. So if you have questions about this line of code, you can ask me at another time. For now, you can try to make sense of it. You don't need to understand it. It's really I just want to isolate these values, but of course, you can simply look at your table and find the values for which there is 5 of that variable. The other thing, okay, here we're dealing with a continuous variable length, right? So of course we're not very precise. We're not saying a leopard is 109.6523 centimeters. So we don't get further than a centimeter. We are rounding up these values. But of course, with continuous variable, each variable is probably going to be unique. So all of them will be not very frequent. Even the ones in the middle, you might not see them very often because it's a continuous variable. So every variable is very unique. So for continuous variables, you might want to lump them together and get increments in your distribution. So first, let me show you. So this is the line of code you can use to make a histogram. So it's the his function. I'm using the length of Uncia once again. This is the number of breaks. I want to get 1 break for every case in the data so that I really get a bar for every variable. This is just some arguments I'm putting. I just didn't want a label for my x-axis. So, oh no, sorry, I do have a label for the x-axis. sorry, this is an old code. So the length, so I put this actually. So you're not confused. It should be actually like this. Length centimeters. So I'm specifying the length. This is just how I want to call the x-axis, both here and there. Yeah. Okay. So it is manually putting that label here, and the y-axis, I want the label to be frequency, and this is what it's doing on the figure. All right, so we're doing our first plot. The main title, I don't want any title for the plot, so I put main and I put something empty. If I decrease the number of breaks, some of the values will be lumped together, which might be a bit more informative for a continuous variable. And you see this is a bit more smooth now, because now this is, okay, 1, 2, 3. Oops, what would it be like 100 and what would it be 2, 4, 6. Well, it's lumping some of the values together basically. So we can see from that distribution here that around this area, then so leopards are more commonly around this size essentially. And if you move away from this, you'll see that less and less you'll see leopards are very small or very big. For example, that one leopard here that is 150 centimeters, there's only one. So it's that little bump here. There's kind of a gap here. So no leopards are around really 140. So this could be just because of our sampling. We only have so many leopards. So maybe if we had more samples, if we had more leopards in our data set, maybe we would find that some of them are around there. But it seems that generally leopards are around that size, right? And there's something strange in our data set. It's here. There's some values are very small for some reason. For those of you who work with leopards, maybe you will know what is going on there. Any ideas? I mean, for you, you've probably worked with leopards before, I think, or maybe not all of you work with leopards. I don't know how this works, but yeah, any ideas why we get these data points there? That's okay. So someone is guessing maybe cubs, and that could be a case. Maybe like maybe we actually found some cubs. I don't know if that's realistic, but that's definitely, that could be a reason. Any other guesses potentially? Guess cubs is pretty a good guess. Okay, someone's histogram. Oh, okay. That error message you're getting, Aliana, with that the figure margins are too large, it's only to do with your computer screen. So if you say, sorry, or maybe error in measuring. Okay. Oh, okay, error in measuring outliers. So maybe, yeah, the figure is just too big. So one thing you can do to circumvent that issue, I will show you some code. I actually have a code already for this, but where is my code? So I put it here. Okay, this is my code for the data set. Right, this is my histogram. No, wait, that's not my histogram. No, that's not the right data set. I think here only. Okay, so this is the code for that first session. And if I scroll down, I'll say, okay, this is when we're working on the UNCI data set. This is my histogram. Okay, so if I run this, I will get that histogram that I put in the presentation. For some of you, this may not work simply because because the margins are too large. So maybe the figure is too big. Maybe try with number of breaks that are a bit smaller, maybe 10. Maybe that will reduce the size and maybe that will work. And okay, and Mustafa is suggesting to move the plot to a separate window, and yeah, you can do that, and maybe that will solve the problem. So for this, you click on zoom, I think.
So sometimes if the window is too small, it just gives an error instead of widening it. So just have to make sure it has enough space.
Yeah. Anyway, don't worry about it. For now, it's not too important. So Anyway, moving on. So one thing I want to do now is, okay, let's have a better look at this data. So now we're done with the presentation, but I want to work a little bit now. We have 20 minutes left to kind of like get a better idea of our data and try to see like why we have these weird points and if they make sense or not. All right. And you'll see that there are some issues that we want to deal with. Okay, so let me get back to this. So now we want to inspect the UNCIA dataset. This is something you want to do pretty much every time you have data. First thing you want to do is get a really good grip on what you did, how your data is structured, how maybe some variables are related to one another, like how, so something I could do, for example, is this. There's a summary function, it's very handy. I could simply have a summary of UNCIA. This is what it tells me here in the console. It tells me that well, that first variable here is simply like my numbers from 1 to 110. I don't really care about that column. Location is a character. It doesn't tell me much about it. Just tells me it's a character of length 110. Same for sex. Not many informations here. It tells me that length, however, goes minimum is 41 centimeters, the maximum. Sorry.
Switch windows.
Am I not in the right window?
No, we can see the presentation.
Oh, sorry. My bad. I thought I was presenting here. Yes, here we are. Okay, so I only typed this for now. Inspect the UNCIA dataset as my annotation so I know what I'm doing if I look at it in 6 months. Summary UNCIA gets you this summary here. So yeah, that column I don't really care about. That's my column location, which has like the summary doesn't give me much information there. Here neither. But on length, because length is already a number, then I get like some measures there. I know that my minimum value is 41, the maximum is 150. I know that the median is at 105 and the mean is there. These are we already had. And we also have the first quartile and the third quartile, which we had also calculated before. Same for weight. By the way, if you want to train yourself, like with what we did today, I would suggest you do that with the weight column. So we didn't touch on the weight column so far, but everything we did, calculating the median, you can try to do that on that column as well. There's something I want to do actually is just this. So if you remember the structure of UNCIA, if I type str UNCIA, the location and the sex column are character. Actually, it's not very useful. When you work with categorical variables, you probably will want these columns to be factors, not characters. And you can very easily convert these columns to factors. And you can do this. Convert location and sex to factor. This is how you do it. UNCIA, I'm going to refer, so which columns are there? Also, something you can appreciate also is that with the $sign, which we've been using before, you can only refer to one column at a time, not two, which is why sometimes the square brackets is a bit more handy. So I want to select columns. So remember, the column is the second index, which is why I'm leaving this blank and then comma, and then the column index will be column 2 and 3, right? So column 2 and 3, which is location and sex, I will put them as factor. UNCIA. Oh, sorry, it won't work. I'm sorry. No, I can't do 2 at the same time. My bad. I have to do them one by one. So I will use the $sign in that case. Location is going to be UNCIA, it's going to be factor UNCIA location. There you go. And then, so I will show you later. I will just do the same for sex, and I put it as factor. You can put either factor or as factor. This will both work. UNCIA sex, run this. And now if I look at UNCIA once again, you'll see that it's a little different. Now location and sex are factors with 2 levels because there's only 2 cases, 2 categories. Categories for location are alt type and Wakan. And sex is either F for female or M for male. Okay. That's a bit more informative. Okay. And if I now look at the summary, you'll see that it's with these factors now, with these columns as factors, it's going to be a little more informative than when we had it as character. So if we type summary Uncia, now you see that location has 2, and it gives you the number for each of these. It gives you the summary. So 41 lepers are from Altai, 69 are from Wakan, and there's 57 females in our data set and 53 males. The data set is so nicely structured. We have almost an equal number of males and females. Okay, so that's the first way to look at your data. I'm just going to check if we have some questions at this point. Okay, yeah, I'm going to get to that. Why we have some small lepers. This is what we're just about to do. So let's have a look. Okay, so now we're getting into, okay, how can we look at the data together? We have only 2 variables, length and weight, and actually these variables are going to be related to one another, right? Why do we have dwarfs? Yeah, we'll get to that. Why do we have dwarfs in our data set? Okay, let's have a look. We know that weight and length are going to be related to one another, right? It's pretty straightforward. Bigger leopard should be heavier, right? So maybe it's a good idea to plot weight against length, right? Let's do that. Plot weight against length. This is with the plot function, and let's see what the plot function expects as arguments. So so I have 2. This is because I have 2 packages in my R that have the function plot. So I need to say I want it from the base R. So this is just the generic plot function. If you haven't installed any packages yet, you might not even get that. You'll probably be taken straight there. So again, the plot will be first X and then a Y. X will be the coordinate points for like the X coordinates and Y the Y coordinates, right? So I can choose which one I want on my X axis and my Y axis. I will put I'll put length as the X axis and weight as the Y axis. So pretty straightforward. So I'll remove the question mark here and simply put as X equal is going to be Uncia length, I said, and the Y will be Uncia weight. Okay. So that's one way to do it. You don't have to put, so this is really to say the Y argument in the function, because the plot function expects the Y argument. I say the Y argument is going to be this. The X argument is going to be that. You don't have to put these actually. You could remove the X equal and the Y equal, as long as you're going to be in the same order. So the first argument will be X, the second argument will be Y. Naming these arguments is useful if you mix them around. So sometimes it's nice to name them to keep track of what is what. So for example, if for some reason I thought the first argument was going to be the Y argument and then the X argument, I will end up with the wrong plot, right? Which is why it might be useful to put, well, this is what I wanted anyway, but if for some reason I wanted length as Y, then I can just I could put Y here equals this and then X equal. Sorry, if it makes sense, basically, yeah, if I name the arguments, I don't need to put them in a particular order within the function because I'm telling R already which one is which. So R knows which one is which. If I don't specify, then R will just assume the first argument will be X and the second one will be Y, because that's how the function is written. The first argument here in the brackets is X and the second is Y. But I can mix them around and then I end up with a different plot with length on the Y-axis now. But I don't want that actually. I want X to be the length. Okay, so now that's a bit more useful. We see what's going on. We see that we have the dwarves there, but the dwarves are quite heavy. They are as heavy, as you can see, as leopards are in that region here. If you look like around that range, like between 30 and 40 kilograms, like this is the way that you would expect for leopards are around there, right? So we have some great theories there, like maybe the tails got chopped off, but like still for a leopard that size, you would expect the weight to be tiny, right? So either we have very fat cubs, which is unlikely. What do you think could be the reason there? Do you have any ideas? Just gonna leave a couple of minutes for people to like maybe look at this graph and decide.
Also, you can just like switch on your mics and quickly tell. It's
Yeah. We're not that many.
Everything doesn't have to be on chat.
So what do we think? Why do we have this? Also, like it seems to be a bit consistent, right? We do have like these tiny, these very big fat leopards, these fat dwarves are. It's pretty consistent. There's a few of them. It's not only one. So what could have happened? We can actually have a look at the data itself. We can subset. It might be informative too, because this plot here doesn't tell you which row it is in your, like it doesn't tell you an idea about are they females, are they males. Often in a data set, when you collect data in the field, you'll have maybe you'll take some notes and you have a column with some notes. Maybe you know who took the data. Maybe it's the same person that took that data every time. And we get an idea of, okay, maybe that person did something with these leopards. All right, we have a pretty good guess here. Maybe the weight is a different, maybe it's a different unit, not kg, although we thought we had kgs.
Or centimeters versus inches.
Or percentiles versus inches. All right. The first thing you might want to do at this point is look at the data frame itself, like for these particular cases. So one way to isolate them is we know that these leopards are less than 60 centimeters in length, right? Okay, so we can try. Blah, blah, blah. So we're gonna subset the data set now. Look at the fat dwarves. So we want Uncia. So again, we're going to isolate Uncia, right? We're going to take something from Uncia. What do we want? So we want to look at we want to look at all the rows, right? So we want all the rows. So we're going to leave that blank. Sorry, no, we don't want all the rows. We want the rows for which these leopards are too heavy.
So we can use this subset function.
We can use a subset function, which I actually never use. I always use the square brackets. I'll just show this first. Maybe then afterwards you can use the subset function. So in the column, I want only the ones. So Uncia when length is less than 60. Look, if I run only this, look what happens. It gives me a false, 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 true, 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 false, 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 and so on. Where it's true is for these particular leopards. So if I put this as the column index, it will only return the ones for which it is true, which is how you can, that's one way of subsetting. If I run this, oh, that is not working. Undefined columns selected. I beg to differ. Uncia length. Sorry, no. I have to put Uncia length.
No, it's right.
I'm confused.
No, I guess.
Sorry, no, my bad. I want all the columns, but I want the rows for which.
Correct.
Yeah. I put them, I switch them around. So this will tell me, okay, these are the rows I want. I don't want the first one. I don't want the second one. That's why they are false, 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 and so on, until it's true. But I do want all the columns, of course. I want to look at all the data that there is for these leopards. So that's what happens then if I do this. So indeed, like all of these leopards are less than 60, and we have their weight. Okay, they are all from Wakan. They are all males. I don't know if that tells us anything. Okay, what about the outlier? I guess we'll talk about the outlier in a second. I'm sorry, I think the course will extend maybe by 5 minutes. If you guys can stick around, that'd be great. I can just tell you what's going on with these outliers. So when I created this data set, maybe you've already, you guys know snow leopards, so maybe you've identified that this data set is fake. I made this up. So I created just a bunch of leopards from different locations, yeah, just to work on this for the course. I created these outliers on purpose. So with this data set, I don't have any more information. So because they obviously don't match what you would expect, this is just impossible. You don't have leopards that are that big and heavy. You could guess what happened and maybe you can try a few things, but without being sure, I would say maybe exclude these data points from your data set before doing your analysis, simply because you don't know whether you made a mistake or not when writing up the data. You're just not sure what's going on. If you knew who took the data, maybe the person who took this data was American, and maybe you know that Americans deal with inches. And it's actually exactly what happened here. I actually put this length as inches, not centimeters, and that is what's happening. So I could convert them back, or I could simply get rid of them. It's kind of your call at this point. If you have your own data, you should know how you collected it and what kind of mistakes you could have done, you could have made. If you have data in a notebook where maybe you've made a typo and you can look at the raw data again and see what happened with these particular leopards. Yeah, maybe you'll realize then that actually, yeah, you switched weight and length, and then you can simply revert them back and carry on with your analysis. But without being sure, I would say maybe get rid of them. What do we think of that outlier though? Should we get rid of it, or what do you guys think? So feel free to talk with your mic or speak in the chat. What do we think of that very big and heavy leopard?
Yep.
Get rid of it. All right. I don't actually, for those of you who are more familiar with snow leopards, is that unreasonable to have a snow leopard who's 150 centimeter? Okay, yeah, for these leopards that are tiny and heavy, we do know the mistake, so we can just convert them back. I'm just saying, if we didn't know, I'm just telling you, of course, what happened here. If you were not sure, maybe it would be safer to remove them because you do have quite a few leopards to work with already. Okay, so for those of you who work with snow leopards on a day, like regularly, like what do you think of this big one, the outlier that's here in the corner? Okay, so some people say we should keep it. So is it unreasonable to have this big, it's a big male. We can have a look again. If I subset this time to look at this other outlier, now I want to put equal. The double equal is important here because that equal, only single equal, it's to assign objects. So R doesn't like this. If you want to mean equal, as in, is it equal to that value? Then you have to use the double equal, which is a logical argument. So for the ones at 150, this is what happened. It's a big male from Wakan. He's 55 kgs. He's 150 centimeters. Okay, so some people think it might be an error, maybe. So my thought on this, and I know this actually from making the data myself. I got this big leopard by chance. I did not create it myself. So the thing is, simply by chance, we just don't have many leopards in that range. We simply have this big male there. And actually, as you can see, it kind of follows the same trend. It's still aligned with the others. So in this case, actually, he's not unexpectedly big. He's not, maybe, I don't know if you'll agree with me, for those of you who work with snow leopards regularly, that 150 is not that extravagant. So maybe you could keep it, and yeah, maybe you would. Yeah, so say he's a big leopard, basically bigger than most of them. He's an outlier for sure, so he will definitely skew the data a little bit by being so big compared to the others. But depending on what you want to do with the analysis, it might be important to keep him. Maybe it's important to look at this particular big leopard. The others, though, the ones that are clearly not following the same trend, this is more evident that this is a mistake in your data. This is something that was either a typo or something happened. And so that the proper way to deal with this, I either try to understand why the data is mislabeled, the data entry didn't happen properly. Or again, if in any doubt, just get rid of them, because in our case, we have a lot of leopards to work with. It's not going to affect our analysis too much to get rid of them. Okay, so I guess actually, I think that's kind of it for today. I don't know if is there anything else we want to do?
No, so
Guess we have some people had some trouble.
yeah, okay. Aliana, just try to reload the data and run the code again.
This code I will put in the drive for everyone to have anyway, so you can have it at the end.
And Haripriya, what exactly do you mean? How to get rid of in code? Oh, how to get rid of the outlier?
How to remove the outliers? Okay, yes. Good
Yeah.
question. Okay, okay. Let's just assume we want to keep the.
So here I'll do the subset function now, like just so you know another way of subsetting.
Okay.
Yeah. Just so assign object.
Okay, so I put Uncia.
Object name, Uncia, without subset. Create a new object.
A new object called Uncia.
Sure. Yeah.
Yeah.
Subset. Open brackets. Name of Uncia. Comma. So right now we're getting rid of the 150 outlier.
Yeah.
So that would be the length.cm, Uncia length.$cm.
Here.
No. That's just in Uncia. Write it again after the.
Okay, like this.
Yeah. No, Uncia dollar.
Uncia dollar.
Yeah, just to make sure it gets the correct. Refer to the column. No, Uncia, comma, Uncia dollar length.cm. Just give
Okay.
me.
Like this.
Yes. Less than 140, because that should include everyone other than the outlier.
Less
correct?
than 60, right? We want to get rid of. We don't want to get rid of that big leopard. We want to get rid only of the.
We'll keep it small brackets, yeah. Then greater than 60, not less than. It will keep the ones that you mentioned.
Oh, sorry, that was, yeah, you're right, sorry. More, then I get, cool. So then I subset it, and you can see that Uncia is now it's no longer 110 leopards. It's
but now
60.
No, it will be
60 is the length from the.
You rewrote Uncia. Yeah, but you wrote over Uncia. You have to load Uncia again.
Okay. So just bear in mind, we calculated the median, the mean in all the previous slides using this data set that was wrong. So this is also why the mean was a bit skewed. It was less than the median, although with this kind of data, you would expect, if you have heard of normally distributed data before, length is normally distributed. And for this kind of data that is normally distributed, the mean should equal the median, almost. And we could see that the mean was actually a bit skewed. It was a bit less than the median. And that was the reason, is because of these outliers. They were pulling the mean away from the median. So you might want to recalculate all of these after getting rid of these, or if you want, you can convert them also. Okay. I guess we will basically stop here. There is one task I want people to do, or try to do, for the next session. If you can't manage to do it, don't worry, because that's the first thing we'll do anyway. I want you to try to calculate a BCI, a body condition index, for the leopard. So I want you to essentially take that data frame Uncia, and I want you to add an extra column that you will call BCI. And you can use any method that you want to calculate BCI. There's a few out there. I will send you a paper that explains that there's different ways of calculating BCI. Sometimes you just do like length divided by the weight, something like this. So it's a pretty simple calculations in any case, but there are different ways of doing it. So I'm curious to know which ones you will choose to use, and yeah, just create that third column. So you can add this to your script so that next time you can rerun the script and get there, this data set with that extra column. And we will work with the BCI, the body condition index. I could stay online a little bit if people have questions.
Just to, yeah, and just to like, you know, one overarching, not what we call it, just tips to remember, which will minimize errors, is if it's a round bracket, it's usually an object inside it. It has to be something that a function can be assigned to. Square brackets always refer to a position in an object, you know, data frame, matrix, vector, whatever it is, row, then column, and Haripriya. So for removing outliers, there are multiple ways you can do it. So how Guillaume did it earlier with the square bracket, you can remove it, or you can remove it with using the subset function. And yeah, and then assignment function and equal to are equivalent, but assignment function can assign globally. Like for example, if you look at the plot function, Guillaume used x is equal to uncial length. So in that particular situation, the assignment function worked only for within the function. If you were to do that with the equal to worked only within the function. If you were to do that with assignment, it would likely assign x as an object which is equal to that.
Yeah.
Okay, and double equal to is comparison. So like Boolean functions, so anything that's like equal to, less
If
than.
you compare, I can show you a really quick example. If I put 1 equal 2, it tells me false, basically, because they're not. If I put 1 equal 1, it tells me true. But if I do this only, then it's an error because it's expecting me to create an object with this, with a simple equal. It's not it's not going to be the logical argument.
Yeah.
Okay, so I hope this was not too confusing for you, and that you got the first grasp on R, and that you kind of start making sense of how it works. Don't worry if you're a bit confused at this point, because we'll work with R, of course, more, and you will build up on this. All right, so if some of you have trouble or had trouble with their code, I will stay online a little bit, and you can ask questions and trying to troubleshoot with me so we can understand what happened. But yeah, other than that, we'll see you all next week. And so bear in mind, I will send that paper so that you can read that paper and understand in which different ways you can calculate BCI and choose the one you want to use, and then work on your code to do that. And we will send the slides for that present that we had today for the presentation, and the code that we ended up with at the end. All right. And I don't know if there's anything else you want to say.
I mean, no, that's it.
Yeah.
And
Okay. So if you guys have any questions, if you have any doubts or want to ask Anne or Guillaume anything, the Google group is available, so you can ask them anything further, any clarification before the session next week. And apart from that, yeah, thank you, Anne and Guillaume. That was really, really amazing and interesting. I got so involved with it as well. I think I can start learning art now.
It's a tough start. I guess it's sometimes difficult to know what will be too fast, because it is a bit tough at first, but over quickly you get used to the logic behind the language, and it becomes very easy.
Yeah, you guys were very clear. That was one thing that I found, and I think a lot of the participants found that as well. The clarity and explanations was amazing. So thank you so much for that.